So I'm going to do two examples from 10-1's homework. And the reason I wanted to do this was because it's slightly different than what we've seen before. Whenever we've done our hypothesis testing, and even in my previous video, we used the t-table, but there was another person who sort of compiled a critical value list who sort of pioneered this study of the correlations, coefficients, and his name was, if I remember correctly, it was Pearson something. Anyway, so Pearson created his own scores, and he compiled a list, and so we're actually going to use his table this time instead of the t-table because he did a whole lot more research, and so he found, I guess you could say, key values for certain alpha values. So that's what we're going to use in this particular case, and I've already uploaded everything to Teams, so I'll be sure to go through that for you and show you the whole process. So the question says use alpha at 0.05 and the Pearson table, and the number of murders and robberies per 100,000 population for a random selection of states, it's a typo, of states is shown. Is there a linear relationship between the variables? You can tell I'm tired because of all the typos. I've spent an ungodly amount of time on some of these resources for you, so hopefully they will be helpful in the long run. So I'm going to go find a couple of these items that I need to find. The first thing I'm going to find is everything's under files, but the first thing I need to have is the Pearson scores. Okay, the Pearson scores are right here. I'm trying to make the blink a little bit. There we go. And I'm going to open that in a second, but it has the list of everything that we need to use for this case. The other thing that's going to be very, very helpful for you guys, and this is what I spent so much time on, is in the Chapter 10 folder. And so I have the notes for this and along with the PowerPoint that you guys see. But right here I have the correlation coefficient template. And I spent so long on this Excel spreadsheet just to make it nice and pretty and easy for you guys to use. So I'm going to ask that you guys do not touch this. You are allowed to download it and you are allowed to work with it on your own, but do not start typing numbers in here. If you open it and start typing in numbers, that's fine. But the issue is if you press even the wrong button, this entire thing is ruined. So what I ask that you do is instead of clicking on it and starting to mess with it, go ahead and click the little plus sign or the check mark off to the left, and then I want you to download it. Okay, when you download it, you are allowed to make any edits to it, and that way if you do make a mistake, you can come back to this page and you can actually re-download it and it'll be good as new. So I've gone ahead and I've downloaded it. It's going to be under downloads. I'm going to go to my correlation coefficient template. And instead of, doing the table like I did before, I'm going to type in my values that I had on that previous screen. And it says enable editing right here. And I'm just going to type it in and it's going to do all the work for me. Okay, so this is what I did for you guys. I love you. All right, so it says marked as final. We're going to edit anyway. So I'm going to do 2.4, 2.7, 5.6, 2.6, 2.1, 3.3, 6.6, and then finally 5.7. Okay, so these are my murders, and now I'm going to do my robberies. This is 25.3, 14.3, 151.6, 91.1, 80, 49, 173, and 95.8. Okay, so I have entered in all of these values, okay, and as you can see off to the left-hand side, I don't have sigma inside of Excel. Unfortunately, I don't have sigma inside of Excel, so I used E to represent it, but it all means the same thing. These are, and it's obviously the number of things that we have, but our correlation correlation coefficient, you can tell it's late, is right here. I forgot to make it 3 decimals, so by the time you download it, it'll be corrected. But you should always have 3 decimals for this. And so now that we have that, and everything else should be at 2 decimals. But now that we have that, we can go ahead and write that down in our problem on our PowerPoint. So I'm going to go ahead and write my R is equal to 0.804, and then I'm going to get started on my hypothesis testing. So first things first, my null hypothesis and my alternative hypothesis are going to be all the same as what I had before, not 1, but 0. And now I'm going to go to my Pearson table and find my critical value. So under teams, we are going to go back to general, and Pearson table has been added right here. And I have, I think, a total of, let's see, 1, 2, 3, 4, 5, 6, 7, 8 data points that I had before. My degrees of freedom is by -2. Let me make this a little bit bigger. Oops. Make it 150. Okay, so my degrees of freedom would be -2, which would be 6. And we are going over to our critical value when alpha is 0.05. So my critical value is actually going to be positive or negative 0.707. All right, so let's go back. So our critical value is going to be positive or negative 0.707. We can draw our picture and sort of get an idea of what that's going to be. And our 0.804, which is our correlation coefficient, is in the shaded region. So we would reject this claim, and we would say, to summarize, there is not sufficient evidence to suggest that there is a linear relationship. All right, and that would be our answer. Okay, so it's a little bit different than what we've been doing, but it's along the same lines. Unfortunately, we're just using a different table, and now that I've given you that beautiful Excel worksheet, that template, you can easily find your correlation coefficient because I love you. Oh wait, hold on. I definitely wrote down the wrong one. It's supposed to be there is sufficient evidence. Sorry. I wrote down the wrong summary. It's late, guys. Give me a break. All right, example number 2. I promise I will write down the correct summary for this one. So we are using alpha is equal to 0.05 and the Pearson table. The average gasoline price per gallon in cities and the cost of barrel of oil are shown for a random selection of weeks in 2015. Is there a linear relationship between the variables? So again, we're going to go to our let me exit out of this, to our Excel spreadsheet, and we have some values in here already, but that's okay. We're just going to enter in our new ones. As you go into your new cell, it should delete any information, and as you're doing it, you can see everything is changing because this is, I just created a workbook for you. It just does everything for you because I'm super nice. 0.21, and we have some extra ones, so I'm just going to go down here and delete these values so that they're not messing with my information. 1.97, 1.96, 2.06, 52, 2.04, 2.00, and 1.99. Okay, so let's delete these. All right, so I can see that my correlation coefficient is going to be up here on that left-hand cell, and it is going to be 0.158. All right, so I will be writing down R is equal to 0.158, and then we can get started. Our null is going to be rho is equal to 0, or there is no significant difference, and the alternative is when it does not equal 0, so therefore there is significant difference. All right, so now the next thing we have to do is go to our Pearson table, because that's what it asked for us to do next. Go to our Pearson table and find our critical values. We have 1, 2, 3, 4, 5, 6 points to look at, and our degrees of freedom are now by subtracting 2. So we need to find our critical values when the degrees of freedom equals 4. All right, so again, our degrees of freedom is going to equal to 4, and we're going to go over when alpha is equal to 0.05. So it looks like our critical values are going to be positive or negative 0.811. All right, so our critical values is going to be equal to positive or negative 0.811. Let's draw our picture. We have our negative 0.811 off to the left and our positive to the right. And that means that our correlation coefficient is actually somewhere in the middle, 0.158. And we can see that it is in our non-shaded area, so we would say we don't reject it. We do not reject it. And also, I'll promise I will write this correctly. There is not sufficient evidence. There's not sufficient evidence to suggest there is a linear relationship. And that is our final answer. All right, so I just wanted to show you guys how to do these problems so that you weren't feeling super lost. All of the problems will be doing this, so just make sure that you are referencing the Pearson table, and please also be sure to use my calculator that I've given you out of the goodness of my heart. Okay, so please text me if you have any issues.